So you could do, remember, graphing was the first way. Second way was substitution. Third way was the elimination. Fourth way was using matrix determinants. And now the fifth way will be called inverse matrices.
Can we go back and get this with the first part of the one?
When it comes time for the test, there will be some specific instructions on how you should solve certain questions. So they may say, solve this by elimination, or solve this using inverse matrices. Okay. Huh?
Like in this case, it's going to be like all the times.
Yep. Or it could be, solve this using the method of your choice. So if it's really weird numbers, it might be good to use matrices. Okay. So this system written in matrix form is, so we can write this system in matrix form, and we've already seen it a little bit. It's going to start with a coefficient matrix. So the coefficients are 2, 3, 5, and 6. We're going to multiply it by our variables, x and y, and it's going to equal our solutions 4 and 7. So coefficient matrix times a variable matrix equals a solution matrix. Are these allowed to be multiplied together? Do the dimensions fit here to multiply the coefficient matrix times the variable matrix? This dimension is 2 by 2. This one is rows by columns. Rows by columns. So 2 by 1. So could I multiply these two?
Yes.
Yeah. So if I go over, remember, as I start at the top left, the top, and I go over, I go down, right? And I add them together. So what's 2 times x? Plus 3 times y equals 2x plus 3y equals 4. I'm just showing you that this is the same thing as this, if you multiply these out. So I take 5 times x, I move over, I move down, 6 times y, 5x plus 6y has to equal 7. Okay? Okay, so how we're going to solve this, we have matrix multiplication. There is nothing that's really called matrix division. Okay, you can't divide by a matrix. But division is just an inverse operation of multiplication. Okay, so for instance, what is 20 divided by 5? Easy. What is 20 times 1/5? Also 4. Okay. So division is the same thing as multiplication of a reciprocal or fraction. Okay. So we say 1/5 is the multiplication inverse, multiplicative inverse of 5. So that's what this looks like here. Multiplicative inverse is a times 1 over a equals 1. 5 times 1 over 5 equals 1. Or 5 divided by 5 equals 1. Okay. So if you have an inverse, you also have to have an identity. You all have an identity? Yeah, who you are. Okay. So if I take any number times 1 over that number, what should I always get? 5 times 1/5, 6 times 1/6, 7 times 1/7 should always be 1. So we say 1 is the multiplication identity. If I add numbers in their opposites, what will I always get? 0. 5 plus negative 5. 6 plus negative 6. Okay. So what we'll have to have here is an inverse matrix that when I multiply it by the left side and the right side, this is going to cancel off. Okay. So we need an inverse matrix to multiply on both sides that cancels off the coefficient matrix We'll leave it at that for now. So that means if it's going to cancel off, we have to have some sort of identity. So there has to be an identity matrix that's going to be the same with all this. So here's the next one. Two matrices that are inverses must equal, here it is, 1, 0, 0, 1 when multiplied. So let's say identity equals 1, 0, 0, 1. Remember our x's and y's, the first column was x's, the second column is y's, you'd have one x and one y. So this identity matrix is always going to be 1s down the main diagonal and 0s everywhere else. So let's say we don't have a 2 by 2, we have a 3 by 3. It would be 1s down the main column, 0s everywhere else. That's the identity matrix. Yep, a lot of binary. Okay, we could have a 4 by 4. Woo, now we're getting fun. So same thing, where do the 1s go? Just this main, it's called the primary diagonal. So 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1. Programming. Alright. We do a 5 by 5, 6 by 6, 100 by 100. Alright, so you get the idea. Identity matrices are just this. Now, guess what happens if I would take any matrix times identity matrix? Would you get 0? Let's take 2, 3, 4, 5 times 1, 0, 0, 1.
2, 0.
No.
Oh, multiplication.
Matrix multiplication, you can't just go spot to spot. So remember, we have 2 rows, 2 columns. Good review for the matrix multiplication. So a 2 by 2 times a 2 by 2, our answer will be a 2 by 2. So first row, first column, I have 2 times 1 plus 3 times 0. So that's just going to be 2, right? First row, second column. 2 times 0 and 3 times 1. You all remembering how to multiply matrices? Good review right here. We'll have to use it today again. 4 times 1 plus 5 times 0 is 4. 4 times 0 plus 5 times 1 is 5. It's the same thing. Isn't that what an identity something should do? Is if you use it, it should end up being what you have. Because your multiplication identity is 1, so anything times 1 equals anything, right? Your additive identity is 0, so adding 0, does that change anything? No. So if you have a matrix identity, if you multiply by the identity, should it change it at all? No. Well, isn't that cool? Okay. But it has to be in that order. The ones have to go down there. Then it's not the identity, and you'd get a different answer. It would be, these would be flipped around a little bit. So it'd be like 3, 2, 5, 4. So here's the first type of questions you're going to have. So R, 2, 1, negative 1, 0, and 1, 2, 2, 1, inverses of each other. So if they're inverses, if you multiply them, what should you get?
1, 0, 0.
The identity. Okay. So what you have to do is multiply together, and if they equal the identity matrix, then they are inverses. So if you remember what the identity matrix is, that it has to be 1, 0, 0, 1, if throughout your process you get something that's not 1, 0, 0, 1, you can be done. You don't have to finish the problem. Okay, and I think this one you should know pretty quick that it's not going to work out. What's that? No. This non-calculator stuff right here, this is just all 2 by 2s. Okay? This is 3 by 3s. Yeah. Solving 3 by 3 systems of equations using matrices on your calculator. So we want to, do you have that here with you today? Maybe I'll try to